This is day 7 of our 30-day countdown to the Further Maths GCSE Level 2. And yesterday we were given the question, calculate the exact value of tan 60 multiplied by sine 45. So it's an exact value question, which means it's a non-calculator. So we need to work out what tan 60 is and sine 45 is, and then multiply our results together. Now, the way I work out these exact values is by drawing triangles. So the first one I'm going to do for the tan 60 is draw myself an equilateral triangle. And the trick is here to make your side lengths 2. Now, if we're on an equilateral triangle, all my angles are 60. And if we drop a line down here at a right angle, it's going to create us an angle of 30 here. And we've split this length here into 2. So instead of it being 2 the whole way across, this bit here is going to be 1. Now, if I remove the extra bits to stop any confusion we might have, we have got ourselves a right-angled triangle. So we can use Pythagoras to find this missing length here. So we're going to have a squared plus b squared equals c squared, where c is the longest side and these are a and b. If we want b squared on its own, we're going to do c squared, take away a squared. So let's put those values in. C squared, so it's going to be 2 squared, which is 4. Take away 1 squared, which is 1. So b squared equals 3. So b equals root 3. So this side here is going to be root 3. Now, if we remember, tan of an angle is the opposite over the adjacent. So if I do this stuff in blue, we've got our hypotenuse. We don't care about this angle of 30 at the moment. We are interested in this angle of 60. So this angle down here, and the right angle is going to give us our adjacent. And this is going to be our opposite. So we're going to get tan of our angle 60 is our opposite, which is root 3, over our adjacent, which is 1. So tan of 60 is root 3. Now, if I want sine 45, I'm going to draw myself a right-angled triangle where my two sides here are 45. We have a right angle down here, and these lengths here and here are 1. So again, we've got ourselves a right angle triangle. If we want to work out this missing length here, we're going to do Pythagoras again. So we've got C, A, and B. So C squared equals A squared plus B squared, which equals 1 plus 1. So C squared equals 2. So C is root 2. So that length there is root 2. Sine of an angle is the opposite divided by the hypotenuse. This is going to give us either angle we can use. So I'm going to use the bottom one, I think. So this is the adjacent, this is the opposite, this is the hypotenuse. So we're going to have 1 over root 2. Now, it's good to get in the habit of rationalising, so I'm going to times top and bottom by root 2. So I'm going to end up with root 2 over 2. So, to finish off this question, tan 60 multiplied by sine 45. We're going to take those two values. So we had root 3 multiplied by root 2 over 2. Remember, this is like root 3 over 1. So we'll times the tops together. Root 6 times the bottoms together. And we're going to get root 6 over 2. So the question for tomorrow. So here we've got day 8's question. We've got a y equals 2x to the 3, take away 5x squared, take away 4x plus 7. And we want to find the stationary points of y. But we also need to state whether these are maximums or minimums.